You're listening to ClareFM, the home of the Brian Flynn Show, weekdays from 12. But first, we return to Morning Focus and GavinGrace.
Thank you, Ron, and a very good morning to you all. Let's keep it with matters meteorological for now, because it's the weather that causes turbulence while we're on a plane, and many of us have encountered just that during our journeys, I'm sure. It's scary, and as we saw recently, it can also be a painful experience. Last month, United Airlines flight diverted to Shannon Airport after experiencing severe turbulence over the Atlantic. Around a dozen or so people were brought to hospital where they were treated for minor injuries. One of those who was on the plane was passenger Gregory Giannicavo, who at that time told ClareFM what it was like.
Well, it was quite the experience, I'll tell you. It was the middle of the night. We were about 2 hours out from London, Heathrow Airport, when we felt a slight shudder. And then these tremendous drops of, it seemed like 1,000 feet each, 4 of them right after the other, just a few seconds between each one of them. And babies were screaming, people were screaming, stuff was flying all over. It just felt like we were going to die. It was petrifying, it was terrifying. In 30 years of flying, I've never felt so scared of a flight, never experienced anything so harsh.
Thankfully, everybody got down relatively okay. Some injuries, as I say, but all of them minor. But it is an incident which put the issue of turbulence back in the spotlight. I'm joined on the line now by Dr. Paul Williams from the Department of Meteorology at the University of Reading in the UK. Dr. Williams, good morning to you.
Good morning, Gavin.
And thank you very much for joining us. This might be a simple question, but what causes turbulence?
Well, that's actually a deceptively complicated question, as it turns out.
I'm good at those.
There's lots of different kinds of turbulence. That's the problem. Flying through a cloud is usually turbulent, for example, because of all of the atmospheric motions in the cloud. So I'm talking about convection here. But the dangerous form of turbulence, the hazardous form, is what we call clear air turbulence. And that is the kind of turbulence that really does strike out of the blue when the plane is flying above the clouds and above the weather systems. There can be clear blue skies, and this kind of turbulence is invisible, so the pilot can't see it. And not only that, but the onboard systems on the plane can't see it either, and that's why it's particularly hazardous to passengers and also to flight attendants who tend to be standing up and moving around the plane, actually.
And are there systems on board planes to try and detect where there could be problems?
There's certainly weather radar, which can detect the clouds and the turbulence associated with clouds. But the clear air turbulence, no, it's invisible. There's nothing on the plane that can see it coming, and that's why it is the problematic kind. There's some experimental technology that's just being trialled at the moment that involves shining an ultraviolet laser, funnily enough, out of the front of the plane. Now, this laser light reaches invisible turbulence and gets reflected back to the electronics on the plane, and by analysing the reflected light, it's possible, in theory at least, to detect that invisible turbulence. And the results from the trials that I've seen look very promising. So the technology is just potentially coming online to be able to detect clear air turbulence, but currently it's not there on any commercial plane.
So will this soon then become a thing of the past?
It could potentially, if the experimental technology shows the promise and delivers the early promise in the results that I've seen, then it could make clear air turbulence encounters at least significantly less frequent than they are today, if not completely eliminating them. The problem is, what the question reduces to is how far ahead can this electronics see? If it's only a couple of meters, then obviously the planes hit the turbulence, within a millisecond or something of the electronics detecting it. If it can see 10, 20, 30 miles ahead, then that might just give the pilot enough time to change altitude or change course. So there's still a couple of questions about this technology, and it's still pretty experimental and in the development stages.
Now, as I said in my introduction, a lot of people, if you've taken flights, you'll have experienced turbulence at one time or another. But the incident that we referred to, the United Airlines flight that landed at Shannon a couple of weeks ago, where people were hospitalised, that's particularly unusual, obviously. I'm presuming that would have hit a particularly bad bit of turbulence, and obviously with those on board unprepared because they couldn't see it coming, that's what led here. But it's still rare, I hope?
It's still rare, so that's the good news if you're a nervous flyer, and many of us are actually. Something like 20 to 30% of people are afraid of flying, and turbulence will be one of the main causes of those fears. But yes, the statistics show that flying is very safe. We know, for example, from scientific studies that less than 1% of the atmosphere contains significant turbulence. And that's why it's so rare. And we also know from looking at accident statistics and databases that for every 1 million flights around the world that take off, there's only one serious injury caused by turbulence. So it really is a 1 in a million sort of rare event. So it is, I hope that's some sort of comfort for anyone who might be going to the airport as we speak.
Very possible, Shannon, certainly down the road, of course.
Yes.
But at the same time, did I see you say recently that while it's still rare, it's actually on the increase?
It seems to be on the increase. So when we look through the accident statistics, we see that there's been a 5 times increase in the number of serious injuries caused by turbulence since 1980. Now that sounds like a big increase, but at least part of that increase is explained simply by the fact that there are more people flying now. So just the fact that we've got more people in the air, you would expect more people to be injured, even if the atmosphere wasn't becoming more turbulent. Now, even after you've corrected the statistics to account for that growth in air travel, there's still been something like a 100% increase in the number of passengers injured. And the scientific evidence is building that climate change may be at the root of this. The study that we've published has been looking into the future using climate simulations, and we've been finding that there could be a 10 to 40% increase in the intensity, the strength of the clear air turbulence in the coming decades. So that might be less good news to any nervous flyers who might be listening.
Well, at least it's not today.
Yes.
It's the coming decades. But it is a worry, and I imagine it's something the industry will I hope it's something they'll take seriously. Sometimes we're not the best at planning for years down the line, but this is an expensive one for the airlines, obviously.
Yes, people have tried to estimate the costs, and in the USA alone, the estimate is that it costs up to $500 million a year, and those costs are things like the passenger injuries, the damage to the planes, and that's internal damage when people who aren't seatbelted get flung around the cabin and damage the cabin. Also the cost of the delays and the diversions. So all of that adds up to quite a significant figure.
$500 million, and that's just in America. So
that's just in the US. So you extrapolate that across the world and you get quite big numbers.
That's huge. Absolutely massive. And that, I suppose, brings us back to the technology that you mentioned and the fact that that's being developed. I suppose you can see from a purely economical point of view why the airlines would want to see this happen and why we could see it rolled out on planes in years ahead.
That's true. Unfortunately, it's quite expensive technology as well. So the business case has been analysed for installing this kind of technology. In other words, someone has calculated, okay, so the airlines are losing a certain amount of money from turbulence. How much would it cost for the airlines to fit this technology? And actually, currently, it would cost them more to fit the technology to every one of their planes than they would save. So that's why that's one of the reasons why we're not seeing this technology rolled out yet. However, as the price of the technology drops going forward in time, and also if the number of turbulence injuries continues to increase as it has done, probably because of climate change, then we might see that business case flip over into positive territory, and we might see the airlines retrofitting their fleet of aircraft with this technology.
Is this technology on new airplanes? Do you know?
No, it's not. It's even in the earlier stages than that. They've done one test flight that I'm aware of. It's a European consortium of organisations and universities and companies that have done a test flight, and I've seen the results from that, and it does look very promising. The only snag really is that it's quite expensive at the moment.
Okay. How big of an issue are we talking? Is it a little bump, for the want of a better term, or is this going to be, seriously discussed at the boardroom tables of the likes of the airplane manufacturers and the airlines themselves, do you think, going forward?
Well, that's a good question. This is quite a long-term increase that we're predicting, and the other point is that turbulence statistics are very variable anyway. I mean, for example, there's more clear air turbulence in winter than summer, and that's why this United flight last month that diverted to Shannon was quite unusual, actually, because to have a flight like that with dozens of injuries in the summer months is very rare. So you've got the variability from winter to summer, and also variability from one year to the next. So what we're talking about is a very long-term trend, superimposed, if you like, on all of this variability. And I think as we go forward in time, and if the climate continues to change as we expect it to, and if the turbulence continues to go up, then we will reach a point, yes, when the manufacturers and the airlines start discussing this at their board meetings, okay. And we might then see the technology being rolled out. We'll see.
It's a bit of a worry, I suppose, for us passengers.
I think so, but I would just re-emphasise what I've said about the rarity of turbulence. Even if you took a flight every day of your life, you'd be very unlikely to be seriously injured by turbulence. It's just that when it does happen, especially these days when people get their cameras out and start filming it on the plane, it's very it's got a great presence in the media, and there's videos on YouTube, and that's partly why we're so consciously aware of it these days, I think.
Okay. Have you ever experienced turbulence yourself as a man who studies it so much?
Funnily enough, I have. I wasn't on the flight that diverted to Shannon, but just a few days before that, I was on another flight over the Atlantic, and we were in what I thought was pretty strong turbulence for an hour or two. And even as someone who studies it, and I know the statistics, and I know it's a very safe form of travel, there's a little voice in the back of my head that was going, this isn't right. Does the pilot know why why is the wing bending up? And it's funny how it grabs you, because it doesn't feel right, but you've got to just try and remember the statistics, and people fly all the time, and as I say, you could fly every day of your life and never once be injured by turbulence. So that's the thing to bear in mind.
It's so reassuring to know that an academic expert has the same fears as the rest of us.
Yes.
Dr. Paul Williams, I really enjoyed our chat. Thanks very much for joining us this morning.
That was a pleasure, Gavin.
Thanks, all the best. That's Dr. Paul Williams there. He's from the Department of Meteorology at the University of Reading. Wear your seatbelts. There's a reason they leave the sign. I know they turn the signs off, but there's a reason when they do so that they say, just leave them on. That's why. Turbulence. But hopefully it won't be a big issue going forward. We've much more to come here on Morning Focus. I'll give you our competition question very soon.